Hello, thanks for joining me in this session, and I hope you're having a great I.O. My name is Chris Ariola, and I'm an engineer on the Google Maps Platform Developer Relations team. I've personally been using Google Maps Platform on my Android apps since the first Maps SDK was released. Now, a lot has changed since then, and I've witnessed how Kotlin transformed the way we write apps by making development faster and, frankly, a lot more fun. For this reason, it's no surprise that more and more developers are choosing Kotlin as their preferred language to build Android apps. That's why today, I'm excited to share with you improvements that we've made to Google Maps Platform Android SDKs and utility library for Kotlin developers like yourself. In this talk, I'll share Kotlin extension or KTX libraries and resources to help you learn how to build Kotlin apps using our SDKs. To start, let's review the different Android SDKs offered by Google Maps Platform. First, and the one you're probably most familiar with, is the Maps SDK for Android, which was released in 2012. The Maps SDK allows you to add a map powered by Google Maps' rich set of data. With Maps SDK, you can also draw on the map by adding objects like markers, polygons, and overlays. The Maps SDK is also complemented by an open source utility library that allows you to easily add other popular features to the map, such as marker clusters and heat maps. And lastly, the Places SDK for Android, which was released in 2015 and revamped in 2019. The revamp was done to use a modern tech stack, enabling faster release cycles so you can see improvements quicker. The Places SDK gives you the tools to build features to help your users find places around them, including businesses and other points of interest. It provides an autocomplete widget and programmatic API to search through Google's database of place information. Collectively, the Google Maps Platform Android SDKs and utility library are used by over 300,000 Android apps that serve over 1 billion users around the globe. Now, can you guess what language these SDKs were built with? That's right, Java. For many years, Java was the only option to build Android apps, and rightfully so. Java is a time-tested language with an excellent developer community. Java is used by many products and services, including the Maps and Places SDKs. Then along came Kotlin, a JVM-based language developed by JetBrains and officially supported by the Android team since 2017. At Google I/O 2019, the Android team also announced that Android development will be increasingly Kotlin first. Kotlin and Java are used by many developers and companies ranging from large enterprise companies to small startups. Kotlin interoperates with Java, which means you can use Java libraries in your Kotlin Android app and vice versa. So you can integrate Google Maps Platform Android SDKs into your app, whether it's written in Java, Kotlin, or a mix of both. But just as how spoken languages have differences in the set of words and semantics to convey ideas, Kotlin has its own language features unique to it that can be used to write code. So how do you take advantage of these features while using a library written in Java? Enter Kotlin extension or KTX libraries. These are lightweight Kotlin libraries that wrap existing Java libraries to expose Kotlin-specific language features such as extension functions and coroutines. So if you're a Kotlin developer, you can use a KTX library to write idiomatic Kotlin, but if you're a Java developer, you can continue to use the Java version of the library. If you're writing apps in Kotlin, using KTX libraries will match your expectations as it enables you to write code using common idioms. And this matters so that you can take advantage of the expressiveness that Kotlin can offer. If you're an experienced Kotlin Android developer, the concept of a KTX library is probably familiar to you already, as Android has a rich set of KTX libraries. Now, while you can write KTX wrappers around Google Maps Platform Android SDKs, we've done that for you and open sourced it so you don't have to. The GitHub pages for these libraries are shown here and also linked on the description of this video. Each Google Maps Platform Android SDK, including the Maps utility library, has a corresponding KTX library. To start using these libraries, add the Maps KTX, Maps Utils KTX, or Places KTX to your app-level build.gradle file. Make sure to check the GitHub pages to find the latest version. Now, let's see the Maps and Places KTX in action to demonstrate one of the things you can do with it. I'm going to go through a sample and write it in Kotlin without the KTX library, and then compare it with how you can rewrite it with a KTX library. One of my personal favorite things to do is to travel and see new places. But like many of you watching this right now, I've been spending a lot more time at home. So for now, I like to travel in a way that I know best, using camera animations. Let's say we want to coordinate 3 actions that take time to complete in sequence. First, we'll animate the camera to Mountain View in California, pause for 2 seconds, and then animate to Mexico City. Let's jump right in. To accomplish the first action, we would call the animate camera method and pass it our first desired destination, Mountain View. Once the animation completes, we'll add the 2-second delay. And finally, after the delay, we'll call animate camera again with the next desired camera update, which is the zoom to Mexico City. As you can see from this example, there's a lot of nesting, and we quickly run into the problem affectionately known as callback hell. Callback hell is a situation where you have nested callbacks which make your code difficult to read and understand, as it's not immediately clear under what callback a piece of code is executing in. Visually, this manifests as having several lines with different indentations. If we had to add even more animations with this piece of code, we would further deepen the nesting, which worsens the problem. So let's take a look at how this can be rewritten with the Maps KTX library. For asynchronous calls, such as being notified when the camera animation completes, the KTX library offers support for suspending functions to be used within a coroutine. So for the first action, instead of calling animate camera, we can call the suspending function version await animate camera. This function will suspend the coroutine it is called on and resume once the animation completes. Next, to implement pausing for 2 seconds, we can call the delay function, which will delay or pause the coroutine it is called on. The delay function is part of the Kotlin X coroutines package, which contains a handful of operations to be used within a coroutine. And lastly, after delaying for 2 seconds, we can call await animate camera again with Mexico City as the destination. Since these functions cause a coroutine to suspend, they need to be executed within a coroutine. Here, I've enlisted the help of the Lifecycle Runtime KTX library, which provides a coroutine scope tied to the activity or fragment's lifecycle. This ensures that the suspending function will be run and stopped at the appropriate lifecycle event. The Lifecycle Runtime KTX library is another good example of using a KTX library to leverage a Kotlin language feature, in this case, a coroutine accessible as an extension property. To clarify what's happening here, for each line, the asynchronous operation will suspend execution until it completes its operation. So for the first method call, await animate camera has to complete its animation before the next operation gets executed. This is unlike regular non-suspending functions where execution continues while the asynchronous operation is in progress. A clear benefit of this approach is that you no longer have to nest callbacks. Instead, you have a flatter and easier to read and understand sequence of actions. Using Kotlin coroutines as suspending functions, you can convert asynchronous callback-based code to sequential code. So if you were to add more logic to this, doing so would be much easier. Let's switch focus to another Google Maps platform KTX library, the Places KTX library, that leverages suspending functions. One of the features the Places SDK for Android provides is the ability to get autocomplete place predictions from partial text. Now, the way to use this API is to build a request and include your desired parameters, such as the query text, followed by invoking the asynchronous callback-based find autocomplete predictions method on Places client. Places client is the entry point for making your request to the Places API. Notice here that you need to add a success and failure lambda to receive the response. Now, to rewrite this using the Places KTX library, you can use the suspending function await find autocomplete predictions to receive the predictions response in a sequential manner. Additionally, the Places KTX library provides an alternative API for building the request itself using a DSL-style API. Generally, the pattern of having await in the prefix of a method name is observed by the KTX libraries to indicate that it is a suspending function. Suspending functions and coroutines are a great way to use the Google Maps platform KTX libraries. Also notice that the functionalities I shared are extension functions, so you can use the same classes you're already familiar with and not have to do a big refactor. There are certainly other features that I won't get into, like name parameters and default arguments, so I encourage you to check out the KTX libraries for yourself. Before we wrap up, I want to also share additional work that we did to help you learn how to use our SDKs with Kotlin. If you're new to Kotlin, Google Maps platform, or if you're looking for ideas on how to use our SDKs, make sure to check out our Kotlin Google Maps platform code labs. These are hands-on guided tutorials that walk you through building an app from scratch using our SDKs in Kotlin. Snippets displayed in our documentation pages now contain Kotlin snippets in addition to Java, so you can easily see how to use one of our APIs in Kotlin rather than having to do the Java to Kotlin translation yourself. And lastly, we also created a Kotlin version of our sample apps open sourced on GitHub, which demonstrate all the functionalities offered by the Maps and Places SDKs. I've covered some features in the Maps and Places KTX libraries, and I've shared with you tools to help you learn our SDKs in Kotlin. Looking ahead, this is only the beginning of our commitment to serve Kotlin developers like yourself. At this time, work is underway on the Java SDKs themselves to improve the way nullability is translated to Kotlin. This is an improvement that is expected to land in the future version of Google Maps Platform Android SDKs. There's only so much we can cover in a short session, so I encourage you to check out the GitHub links on this slide. We have an open issue at the moment to add Kotlin Flow to the Maps KTX library that we're actively looking for contributor help. Check it out if you're looking for an open source project to help out with. Otherwise, if you have any suggestions on what you'd like to see next, file an issue, or better yet, send us a pull request. Thanks for watching from wherever in the world you're tuning in from, and have a great time at I/O.